Okay, so today we're going to do operations on polynomials. And quick definition, a polynomial is one or more monomials put together by addition or subtraction. Here's an example of a polynomial. So monomial is a vocab term that you should know. Monomial, just one term. So an example would be negative 2x to the cubed, negative plus like positive 8x, negative 3x to the fifth, 4, 1, x, right? So if we look over here, we're just adding them all together, or adding or subtracting them, right? Poly means like many. So if you ever forget, just think of like a polymer. It's like a mix of different materials, like polyamorous, right? When people are like dating multiple people, right? Okay, so each exponent must be a whole number. The coefficients must be real numbers. So we can't have like x to the power of 1/2.
Or x to like 7.5 powers.
Right. And then we also can't have a coefficient that is not real. So we can't have like square root of negative 4x, right? It's not allowed. It needs to be a real number. Okay. These are some other vocab terms that are important. Constant term, the only term without a variable. So in this example, it's 1, right? It doesn't have any variable next to it. Degree is the largest exponent of the variable. So if we look here, we have 3, 1, and 5. So 5 is the largest. Leading coefficient, the coefficient of the degree term. So even though this guy's in the front, this is our degree term. So our leading coefficient is going to be negative 3. And then in standard form, we write the degree term, and we have like decreasing exponents. So if we were to write this in standard form, we have f of x equals negative 3x to the fifth minus 2x cubed plus 8x plus 1. So we go in decreasing degree order. And see, now we can see that it's in the lead, right? This is our leading coefficient. It's in the front. So in standard form, it's always going to be the front one. But see here, it wasn't in standard form. So we had to redo it.
3x to the fifth and then 2x.
Right, just a reminder, this is the first power, but we're not going to write that. Okay. So add, subtract, and multiply polynomials. So this is the most common operations you'll do. And the biggest thing to remember is just to keep the same rules that you would do before. So something that's tricky is sometimes people see these two parentheses and they think that they should multiply, but it's actually just saying I want this quantity added to this quantity. So really we're just combining like terms. So right, we're adding this all up. So we have 6a cubed plus 5a plus a plus 6a cubed minus 2. We have 3 a's here, so we're going to combine these. We get 12a cubed, and we have 2a terms there, so we get plus 6a, and then finally at the end we have minus 2. Okay, so for this one we need to be careful because there's a negative, so we're going to distribute the negative. So we have 4x to the fourth plus 2 minus 7x squared, right? Minus x to the fourth minus 7. And then we're going to combine like terms. We have 2 terms with 4 as our degree. So we have 3x to the fourth. And then we have this guy by himself, minus 7x squared. And then we have 2 constants, oh, this is a positive, right? Because it's minus negative. So that's plus 9. Always got to be careful. Double check. Make sure you're not making any mistakes. Alright. This one is going to multiply polynomials. And there's going to be 2 methods. We're just going to do our normal distribution. And then we're going to do box method. So for the distribution, we're going to take this first term and we're going to multiply it across all of them like we normally do when we distribute. And then we're going to take this other guy, we're going to distribute that. So let's start. So we have 7n squared plus 7n 6n plus 7n 3 plus n squared plus 6n plus 3. Right, this is the same because this is just 1. So 1 times n squared is just n squared. So now we're going to multiply them across. So we get 7n to the third plus 42n squared plus 21n plus n squared plus 6n plus 3. And then finally we combine like terms. Alright, this is the distribute step. So it's a little cramped here, sorry, but we have 7n cubed plus 43n squared plus 27n plus 3. And then our box method, we have a 2, right? A binomial times a trinomial. So we're going to have a 2 by 3 box. And we have 7n and 1. And then we have n squared, 6n, and 3. And we're going to multiply them across these boxes. So we have 7n cubed, 42n squared, 21n, n squared, 6n, and 3. And then we're just going to add them all up together. And combine like terms. Oops, there's a little n there. Plus 3. Alright, so we get the same answer for both. And that's multiplying polynomials. Alright, so with our polynomial unit, we're going to do a lot of factoring. So we're going to review some factoring today. You should have seen factoring before, but it's always good to review. So we have 4 types. We have difference of squares, factor by grouping, quadratics with the leading coefficient, and quadratic form. So difference of squares is the one that people forget the most, but it's the quickest. So difference of squares, we have a squared minus b squared equals a minus b, a plus b. So this is a vocab word, but these are conjugates. Right, a conjugate is when one of them you have the plus sign between them and the other one you have the minus sign. And if you ever see something that can be broken down into squares, you can do the difference of squares. So let's take this one over here. So your first step, I'll write this over here in a different color because it's so important. First step of factoring always is find a greatest common factor if you can. Right? So I'm going to do this. We see right now that there's a greatest common factor. We could pull out a t, and then we're left with t to the 4th minus 16. So if we look here, we can see that these are both perfect squares, right? T to the 4th equals t squared squared, and 16 equals 4 squared. So we can write that as t squared minus 4, t squared plus 4. And then if we look here again, there's another perfect square because you can break down the t squared into t and t and the 4 into 2 and 2. So we have t minus 2, t plus 2, t squared plus 4. So that was an example with 2 perfect squares. And this is our final factored form. This guy right here can't be broken down any further because it's not a minus there. So this next one, so we look and there's no greatest common factor. So now we need to break up our perfect squares. So we have 81x squared can be broken up into 9x, that whole thing squared. And then 100y to the 8th can be broken up into 10y to the 4th squared. So we're going to make this 9x minus 10y to the 4th, 9x plus 10y to the 4th. And even though this looks super complicated, we're just using the same strategies of perfect squares. And this can't be factored any further because these two aren't perfect squares. Right, 9 is, but you need x squared, and then 10 isn't. So we just stop right here. This is fully factored. All right, factor by grouping. You could do factor by grouping with 3 terms or 4 terms. So if we look here, right, we see that we have this v to the cubed, and immediately you're like, I don't know how to factor that. But we're actually going to do factor by grouping. So when we see 4 terms, we always want to check and see if we can factor by grouping. So we're going to take this guy, and we're going to take this guy, and we're going to try and find our greatest common factor. So if we think here, both these numbers are divided by 7. And then they both have v's to give, so we can take out 2 v's. And then whatever's left over, we have 8v minus 7. And then if we look over here, both of these are divisible by 6. And then what do we have left? We have 8v minus 7. So the trick is, if these two are the same, then we know we can factor by grouping. Alright, so we have 8v minus 7. So what we're going to do is we're going to combine these terms into 7v squared plus 6. That's one factor. And then the other factor is 8v minus 7. Alright, this one's looking crazy, but it's the same thing. So let's pull out our greatest common factors in each pair. So 42, these probably have a common factor. It's 21, so a good way to see what factors there are is to do 147x, and then if you look at your table, divided by x, you can look at your table and find the factors, right? So if we look here, we see 7 and 21, and we know that 42 is divisible by 21. So we're going to have 21, both of them have a's, they both have d's, and so then that's our greatest common factor between those two. What's left is 2c plus, right, 147 divided by 7 is 21, so it's 7. And then this one has an extra d. And then here, we could do 126. Whoops. We do our table. We can see that 18 and 7. So we go minus 18x d squared. And then we have 2c plus 7d, right? So these should be the same, so that sort of gives you a hint of what it can be if you're getting stuck on the factoring. And right, remember, this is a negative. If I was to distribute this negative, it would turn this negative. So that's why it's a positive in the middle, because this negative would make that negative and that negative, which matches the original. So now we just combine our like terms. Or we have our like factors here. We're going to take out these in front. 21a squared d squared minus 18xd squared. And then we have 2c plus 7d. And we actually could factor a little bit. Oh, actually, no, this is it, right? We can't do difference of squares or anything, so this is our final factored form. I guess if we wanted to, we could pull out a d. So we could do d squared 21a squared minus 18x 2c plus 7d. We could do that. Right, so this is the greatest common factor in that guy.